Hi, and welcome to the Unit 1.3 and 1.4 Foundations of Chemistry video. This is supplement part 2. In 1.3, we looked at mole maps, and at 1.4, we looked at mole maps and stoichiometry. And the focus of both of those lessons was how do we quantify matter. For this supplement, we are going to dive into some of the equations that we utilize for those sorts of problems. So let's just quickly go over again what a mole map is. A mole map is a tool that we use to convert from one quantity of a substance to another. And the system that we use to sort of solve these mole map problems are analyze, plan, solve system, where we analyze by identifying our given and our find. Then we make a plan, and that's where the mole map comes in. We sort of map out how to go from a given to our find. So for example, if we were given mass and we need to get to the number of particles, we would see that we would go from mass to moles and then from moles to number of particles. The same way that you would use a map sort of like on your phone or whatever to go from one town to another, the same thing that we do here. Once we have our plan, then we would solve using either the plug and chug method, which is where you plug the numbers into the equation in the order in which you pass them. So if you were started with mass, you would plug your given information in here to get your moles, and then you would plug in your moles to get your number of particles. So that'll be the plug and chug method. The other method is dimensional analysis, where you're using the information in both of these equations to cancel out units you don't want and keep the units you do want. Okay, so in the last video, we looked at the part of the mole map that involves going from moles to number of particles. And then we looked at the part of the equation that goes from moles to mass and vice versa. And as you can see in that equation, we deal with mass and molar mass. Now for this video, we're going to look at the part of the mole map that deals with molarity. And this is probably something that's new to you, unlike mass and number of particles. So we're going to learn a little bit about what molarity is first. So what is molarity? Molarity measures concentrations of solutions. And the equation for molarity is equal to moles of solute over liters of solution. So we got to break that down a little bit more because there's some terms there that you may not know. Now, liters is just a unit for volume. So that's the unit that we utilize in molarity. The volume must be in liters. What about these other terms like solute and solution? A solute is, when you're making a solution, is what's being dissolved. So if you think about making a Kool-Aid solution, like Kool-Aid to drink, the solute would be the Kool-Aid powder. And some people try to memorize it because it's a solute, sounds a little bit like solid. So oftentimes your solutes are solids. They're not always solids, but that's a very common, solutes are often solids. So that may help you memorize it. So the solute is like your Kool-Aid powder. The solvent, on the other hand, is what's doing the dissolving. So if you were making a Kool-Aid solution, you would take the powder and you would dissolve it in water. So the water is the solvent. The solution is the result of that. When you mix the solute and the solvent together, it's the Kool-Aid drink. So it's not the water, it's not the Kool-Aid, it's the Kool-Aid drink. Now we talk about this word concentration. We said molarity measures concentration. So what is concentration? Concentration just basically tells you how much of the solute is dissolved. And so we have to think about, well, if we look at these three solutions here, which one of these do you think is the most concentrated? Is it the first one here, or is it the last one? And you notice the first one is a darker blue and the last one's a lighter blue. So which one of these do you think is the most concentrated? If you guess the last one, the first one, you would be correct, because as you can see here, this one is a darker concentration. So that means that there's more solute. If there was like a blue solute that we put in there, it's more solute that's dissolved in. And so because the concentration here is higher, that means its molarity will be higher. So if we look at the molarities of this solution, this is 2.0 molar. And then for the lightest one, it's 1.0 molar. All right. Well, in order to fully understand how to utilize this molarity equation, we also need to know how solutions are made in chemistry. And the tool that we use for that is called a volumetric flask. And here are 4 examples of volumetric flasks of varying size. The largest volumetric flask is 1,000 milliliters, and the smallest one is 100 milliliters. So volumetric flasks are used to make solutions of a known concentration. For example, if you wanted to make a 3.7 molar solution of sodium chloride, you would use a volumetric flask. And these tools are very precise, so they're usually calibrated with high precision, and that could be like 1 or 2 decimal places. Now, when I say calibrated, what do I mean? You will notice that in each of these, there are these lines at the top, these light blue lines at the top. The way that it works is when the volume of the liquid inside the volumetric flask reaches that line, that's that volume corresponds to the volume of the flask. So in this case, if the liquid reached here for this first flask, it would be 1,000 milliliters. That means the volume of the solution would be 1,000 milliliters. Okay, so how do we make a solution with a volumetric flask? All right, the first step is you're going to have to weigh out your solute. So again, your solute will be your solid like Kool-Aid powder, or in this example, copper sulfate. And then once you weigh it out, you would add it to the flask. So here we just added the copper sulfate solid to our flask. And then the next step is to add some solvent. In the case of this solution, our solvent will be water. So we would add some water to it. But we wouldn't fill it up to the top. We would just pour in enough so that we can mix it to dissolve. And so we keep mixing it until all of it dissolves. Then after all of it dissolves, we would add solvent to the meniscus. So that way we can bring it to the desired volume. All right, so once we have our solution made, well, how do we use that information sort of like to calculate concentration? Well, the way that we do that is, let's say if we weighed at 1.59 grams of copper sulfate, if we did the math using the moles is equal to mass over molar mass equation, we would determine that this mass, 1.59 grams of copper sulfate, corresponds to 0.01 moles of our solute or copper sulfate. Okay, once we have that information and once we make our solution and bring the volume all the way up to the meniscus, we know that the volume of the solution according to this volumetric flask is 500 milliliters. Now, since the molarity equation, we have to use liters of solution, not milliliters, we would have to convert the volume to liters. And now we have the two values that we need to calculate our molarity. So we would have our 1 mole of solute and our volume is 0.5 liters. We would plug that into the equation and then that will give us our molarity. Now, if you wanted to make a 0.02 molar solution, you would sort of have to do this process backwards. What you would have to do is you would have to set your molarity to 0.02 molar. If you knew you were using a 500 milliliter volumetric flask, or if that's the amount of solution that you wanted, then what you would do is you plug in your volume, sorry about that. So you have your molarity that you know the one you're aiming for, the volume of your volumetric, and you would use that to calculate your moles. And then from there, you would use your moles to calculate the mass of the solute you need to get to that number of moles. All right, now that we've seen how to use this, let's try our last CFU here, which is what is the molarity of a 200 milliliter NaCl or sodium chloride solution made from 12 grams of sodium chloride? So here's an image here. In here we have 12 grams of sodium chloride, and we're making it into a 200 milliliter solution using this 200 milliliter volumetric flask. Pause the video now, and when you press play again, the answer will be revealed. Okay, so our equation here is molarity equals moles of solute over liters of solution. Whenever I'm using the molarity equation, I typically like to use plug and chug, not dimensional analysis, because it's just so much easier. So anyway, so I have my my mass, I know that it's 12 grams. I'm going to use the moles equal to mass over molar mass equation, whether you do plug and chug or dimensional analysis, but you're going to use this equation to help you solve for the moles of NaCl. And so we get our moles of NaCl, or our moles of solute, to be 0.205 moles. And we'll plug that number into the molarity equation up here. Now, let's look at our volume. Remember, the volume must be in liters. So we're going to convert from the volume solution from being 200 milliliters to 0.2 liters. And once we have that conversion done, we know that we can just plug it into our molarity equation, and then that will give us the molarity is equal to 1.00 molar. One quick note, you may be asking yourself, how do you convert from milliliters to liters? This is something that you should know in AP, that 1 liter has 1,000 milliliters in it. So the prefix milli tells you that it's 1/1000th of that unit. Okay, so now that we've gone through looking at the mole map, it's important now that you do some practice and you have some level up mole map and stoichiometry practice. I'm going to talk about each of the levels for you, starting with level 0. So the level 0 problems are straight using the equations that you see here, and that's when you have one substance and you're using these 3 equations that you find on the mole map to help you calculate an unknown. So this is just getting practice using the equation. For level 1, you actually have to use the mole map, and that's because you're given one substance, but you have to convert from given quantities of a substance to find another quantity. So for example, you could be given the mass of a substance and need to find its molarity. Or you could be given the molarity of a substance and need to find its number of particles. So that's where the mole map is helpful, because you notice you'll have to use 2 equations, at least 2 equations in this case. For the level 2 problems is where we're now going into stoichiometry. Remember, stoichiometry is where you're using molar ratios to convert from one substance to another. So for levels 0 and 1, we've dealt with one substance, like it was either all water molecules or all sodium chloride solution. For level 2, you're not dealing with one substance, you're dealing with 2 substances. And the mole ratios are going to come from either the subscripts in the chemical formula, or they're going to come from balanced equations. So if you're starting with substance A, you need to go to substance B, you would use whatever the mole ratios are to convert from one substance to another. And this will be an example where dimensional analysis is helpful. Finally, for the level 3 problems, you're using both mole maps and stoichiometry. So in this case, you wouldn't be given the moles of substance A, you would be given the mass of substance A, for example. And you would have to convert from mass of substance A to mole of A. Then use your mole ratios to convert from moles of A to moles of B. And then from there, whatever they're asking you to find for substance B, it could be the molarity, the number of particles, or the mass. All right, so now it's your time to try these problems, level up. You're going to check your answers online. I hope you found this video helpful. Have a quality day.